In this lesson, our goal is to solve quadratic equations. Now, there are many ways to solve quadratic equations. We're going to start with simple ones. Solving quadratic equations by finding square roots. For example, x squared equals 16. We want to solve it. We want to get the x by itself. If it's squared, we unsquare it. Remember when we do that, we get positive and negative of the square root of 16. So positive and negative 4. And sometimes it's as simple as that. Because remember, if we check it, 4 squared makes 16, check. And negative 4 squared makes 16, check. Both are true. Now, if it's not a perfect square, then we're just going to do it by simplifying the radical. 20 is the same as 4 times 5. Square root of 4 is 2, and 5 does not have a perfect square in it. If I don't already have the x squared by itself, then I move the other stuff away. So I get down to the x squared being by itself, and then I have the same thing I started with there. Take the square root, x equals positive or negative 4. Same idea here. The x squared is here. I'm just adding a little bit more to the issue. I've got to subtract negative 2, or I've got to subtract the 2. So 4x squared equals 16. Then I have to divide by the 4. And therefore x squared equals 4. And then I'm ready to take the square root. So sometimes there's a few more steps involved. X equals positive and negative 2. With quadratics, we're usually going to get 2 answers. Beefing it up a little bit, notice how it's not just the x that's squared, it's all of this expression that's squared. So we do the square root to get rid of the squared. X minus 3, whoops, I don't need those parentheses here because the square is gone. So x minus 3 equals positive and negative 4. Now when I have two things that it equals and I still don't have x by itself, I'm going to split it up. X minus 3 could equal negative 4 and x minus 3 could equal positive 4. Then I solve each of those equations. Add 3 to both sides here, add 3 to both sides here. In this one I get x equals negative 1, and in this one I get x equals 7. Now don't rush through these, take your time. Here, the x squared term is not yet by itself, so I add 2 to both sides. X minus 3 squared equals 16, and now I'm to the point where what I did there. Going through those steps again, I get rid of the square, take the square root. X minus 3 equals positive and negative 4, and I split it up and I do x minus 3 equals negative 4, x minus 3 equals positive 4. Add the 3 to both sides, and I get x to be negative 1 or 7. Maybe pause the video and try number 7 on your own. See if you can do that. It looks complicated, but it's not really that much more. Here's the squared term. First, we subtract the 4. So 2 times x minus 3 squared equals 32. Then get rid of the 2 that's multiplied, so divide. X minus 3 squared equals 16. Notice what I have? The same thing that we had here. So then we get the same answers, negative 1 and 7. Now, what if you don't yet have a binomial squared, meaning the thing in parentheses like x minus 3 squared, and all we had to do was take the square root? Then we have to first factor that perfect square trinomial. Let's look at some examples. Remember in the last lesson we had a perfect square trinomial like this and we factored it. How did we do that? We looked at the x term. Negative 6 is the coefficient. We divided it by 2, negative 3. This was the number we used in our factor, so x minus 3 squared. Now we should always check that we actually have a perfect square trinomial. So negative 3 squared equals 9, and 9 is the constant in the trinomial. So yep, we have a perfect square trinomial that can be factored into this binomial squared. Let's write the rest of what the equation says. Equals 16. Now I don't want that squared because now I'm trying to solve for x. So how did we get rid of those before? That's right, take the square root. X minus 3 equals positive and negative 4. And then we split it up. X minus 3 equals negative 4. X minus 3 equals positive 4. You've done this one before. We get negative 1 and 7. You want to pause the video and try the next one on your own? Come back and check it. Alrighty, 8 divided by 2 is 4, and 4 squared is 16, and 16's right there, so we use that 4. X plus 4 squared equals 25, and now I can take the square root to get rid of the square. X plus 4 equals positive and negative 5. Two equations. X plus 4 equals negative 5, x plus 4 equals 5, and solve each of those. Subtract 4. So x equals negative 9, and x equals 1. I agree. It's fun. Now, what do we do if the equation does not already have a binomial squared or a perfect square trinomial? Oh my gosh, they get harder and harder. Well, you know how to complete the square, so let's do that first, and then we'll factor. What does that look like? Well, here's the coefficient of the x. 14 divided by 2 makes 7. 7 squared makes 49, and that does not say 49. So we want it to say 49. There's some different ways you can do it. I suggest getting rid of what we don't want, add it to the other side, it's gone, and then put there what we do want. We want to have 49, so let's say plus 49, but we do it on both sides. Let's write down what we have after doing that. X squared plus 14x plus 49 equals 0 plus 15 plus 49 is 64. Now we can factor this perfect square trinomial. Remember, half of 14 is 7, so x plus 7 squared. The rest of the equation says equals 64. Now I want to get rid of the squared, so I take the square root. X plus 7 equals positive and negative 8. Two equations. X plus 7 equals negative 8, and x plus 7 equals positive 8. Subtract the 7 from both sides, both equations, and we know that x equals negative 15 and 1. Pause the video, try the next one on your own, come back and check your work. Did you want to stick around and see how it's done? If not, fast forward to the answer and check it. 2 divided by 2 is 1, and 1 squared is 1. Not 5. Uh-oh. Get rid of it. Minus 5 on both sides. Now it's gone. I want 1 to be there, so add 1 on both sides. Phew! Crisis averted. X squared plus 2x, and the number that we wanted plus 1 equals 1 plus 0 minus 5, negative 4. So here's our middle term. 2 divided by 2 is 1, and 1 squared is 1. Uh-oh, that's not 1, so let's get rid of it. Minus 5 and minus 5. Gone. We want 1 to be there, so plus 1 on both sides. Now, phew, crisis averted. X squared plus 2x plus 1. That can be factored into x plus 1 squared equals 8 plus 1 is 9 minus 5 is 4. Now we can take the square root, square root of both sides, x plus 1 equals plus and minus 2. So x plus 1 equals negative 2, or x plus 1 equals positive 2. Subtract 1 on both sides, x equals negative 3, or x equals 1. Last example. What do we do if we have a leading coefficient greater than 1? Divide by that coefficient first. So I see there's a 4 here. I don't want it there. Divide both sides by 4. We end up with x squared minus 10x minus 3 equals 1. Now we try to complete the square. Let's look and see what we have to do. Next to the x is negative 10. Divided by 2 is negative 5. Negative 5 squared is 25, but that doesn't say 25, so let's get rid of it. I wanted to say 25, so let's add 25 to both sides. Don't forget to do it on both sides. Now we have x squared minus 10x plus 25 equals 25 plus 1 is 26, and then 29 total. Now we're going to factor x minus 5, remember the number we got by taking half, squared equals 29. Now we can take the square root of both sides. X minus 5 equals positive and negative square root of 29. I can't take the square root of 29, so we'll just leave it. Since I can't take the square root of 29, 5 won't add to it, so I'm still having to get the x by itself, so I'm still going to move the 5 by doing plus 5, but since I can't combine those unlike terms, my answer is just 5 plus or minus the square root of 29. And we did it!